Hi everyone, today I am here to discuss a topic from Unit 8 Redox Reactions plus 1 Chemistry. Redox reaction is a reaction in which both oxidation and reduction takes place simultaneously, that means at the same time. Today in this session we will discuss about types of redox reactions. There are mainly 4 types of redox reactions. They are combination reactions, decomposition reactions, displacement reactions and disproportionation reaction. So, let us discuss in detail about each. Combination reactions. In this type of reaction, 2 or more substances combine to form a new compound. So, in general this reaction is represented as A plus B gives C. Let us see some examples. C plus O2 gives CO2. So, this is a combination reaction. Carbon is burned in the presence of oxygen to give a new compound, that is carbon dioxide. So, let us see whether it is a redox reaction. The oxidation number for carbon is 0, since it is in the free state it is 0. Then O2 is a homonuclear diatomic molecule, so it is again 0. Then to calculate the oxidation state of carbon, we do not know the oxidation state of carbon, but we know that the common oxidation state of oxygen is -2. So, here CO2. So, let us take for carbon as X, oxygen is -2, all together it should be equal to 0. So, X plus -2 into 2 is equal to 0. So, X minus 4 is equal to 0 and X is equal to 4. So, this is the oxidation state of carbon. So, always remember while writing the oxidation state, you are supposed to write only the oxidation state of a single atom on the top. So, here carbon 0 becomes plus 4. The same way O2 0 becomes -2. So, carbon 0 becomes plus 4. So, this is oxidation because there is a increase in oxidation number. Oxidation is a process in which there is an increase in oxidation number. So, here the oxidation number from 0 it is changed to plus 4. So, it is oxidation. Then oxygen 0 becomes -2, that is reduction. As we all know that reduction is a process in which there is a decrease in oxidation number. So, this is an example for combination redox reaction. Let us see one more example. Mg plus N2 gives Mg3N2. Calculate the oxidation number. Here for magnesium it is 0 since it is in the free state. N2 is homonuclear diatomic molecule, so it is 0. Then Mg3N2. So, we have studied that magnesium belongs to second group. So, all second group elements the oxidation number is +2. So, here it is +2 and we do not know the oxidation state of nitrogen here. So let us calculate the oxidation state of nitrogen. Mg3N2, Mg is plus 2, N is X. Let us take it as 2X. Since we have 2 nitrogen here, we will take it as 2X. So we have 2 into 3 plus 2X, all together it is equal to 0. So 6 plus 2X is equal to 0. Then 2X is equal to minus 6. X is equal to 6 by 2, that is equal to minus 3. So Mg0 becomes plus 2 and nitrogen 0 becomes minus 3. So 0 becomes plus 2, that is oxidation. There is an increase in oxidation number. Then N20 becomes minus 3, that is reduction. There is a decrease in oxidation number. So this is combination reaction. Now let us see the second type, that is decomposition reaction. Decomposition reactions. It is a type of reaction in which a compound is broken down into 2 or more substances. In general, it is represented as A gives B plus C. So let us see few examples. (2H2O) gives 2H2 plus O2. So this is a decomposition reaction. Here water is decomposed to H2 and O2. Let us calculate the oxidation number. We know that the common oxidation state for hydrogen is plus 1 and oxygen is minus 2. Then H2 homonuclear diatomic molecule, it is 0. O2 again it is 0 because it is a homonuclear diatomic molecule. Here we can see that hydrogen plus 1 becomes 0 and oxygen minus 2 becomes 0. Plus 1 is reduced to 0, that is reduction, and minus 2 is oxidized to 0, that is oxidation. So this is an example for decomposition redox reaction. Another example, 2HI gives H2 plus I2. The common oxidation number for hydrogen is plus 1, so iodine is minus 1. We know that all together it should be equal to 0. Then H2 0, I2 is also 0. So hydrogen plus 1 becomes 0 and oxygen minus 1 becomes 0. Plus 1 is reduced to 0, that is reduction. Minus 1 is oxidized to 0, that is oxidation. So these are examples for decomposition redox reaction. Now the third type is displacement redox reaction. It is a reaction in which an element displaces or replaces another element from its compound. In general, it is represented as A plus BC gives AC plus B. So here A displaces B from BC. So let us see few examples. First example, Zn plus CuSO4 gives ZnSO4 plus Cu. So let us calculate the oxidation number. Zinc, since it is in the free state, it is 0. Then sulfate SO4 2 minus, so it is minus 2, so copper is plus 2. Together it is 0. Then ZnSO4, Zn is plus 2, sulfate is minus 2 and copper it is 0. So, zinc 0 becomes plus 2 and copper plus 2 becomes 0. So, here you can see that there is an increase in oxidation number which represents oxidation. And here there is a decrease in oxidation number because plus 2 becomes 0. So, this is reduction. Another example, Mg plus 2HCl gives MgCl2 plus H2. So, here you can see that magnesium displaces hydrogen from hydrochloric acid. The oxidation number, magnesium in the free state it is 0, the common oxidation state for hydrogen is plus 1, Cl is minus 1. Here magnesium belongs to second group, it is plus 2 and Cl it is minus 1 and H2 it is 0 since it is a homonuclear diatomic molecule. Then magnesium 0 changes to plus 2, then hydrogen plus 1 changes to 0. So, here 0 to plus 2 is oxidation, there is an increase in oxidation number, then hydrogen plus 1 to 0 it is reduction, there is a decrease in oxidation number. So, these are examples of displacement reaction. Now, the last type of redox reaction is disproportionation reactions. Let us see the examples first. 2H2O2 gives 2H2O plus O2. So, this is a disproportionation redox reaction. So, this is hydrogen peroxide. We have studied that the common oxidation state of oxygen is minus 2 except for peroxides. For peroxides it is minus 1. So, here for oxygen it is minus 1 and hydrogen is plus 1. So, all together it will be equal to 0. Then H2O, hydrogen is plus 1, oxygen is minus 2 and O2 it is 0. Oxygen minus 1 becomes minus 2. The same oxygen minus 1 becomes 0. So, here you can see that the same oxygen, the element oxygen undergoes oxidation as well as reduction simultaneously. That is, oxygen minus 1 is changed to minus 2. So, there is a decrease in oxidation number, that is reduction, that is reduction. Then oxygen minus 1 is changed to 0. There is an increase in oxidation number, that is oxidation. Such redox reaction in which the same element undergoes oxidation and reduction is called disproportionation reaction. Let us see one more example. Cl2 plus H2O gives HClO plus HCl. Let us calculate the oxidation number. Cl2 it is 0. Then hydrogen is plus 1, oxygen is minus 2. Then HClO, hydrogen is plus 1, oxygen is minus 2. Let us calculate for Cl, that is HClO, hydrogen is given plus 1, oxygen is minus 2. We do not know the oxidation state of Cl here, let it be X. So, 1 plus X minus 2 is equal to 0, X minus 1 is equal to 0 and X is equal to plus 1. So, altogether it is equal to 0. Then HCl plus 1 minus 1. So, here you can see that Cl0, the reactant side becomes plus 1. The same way Cl0 becomes minus 1. Here in the first case 0 becomes plus 1, that means it is oxidized because there is an increase in oxidation number. Then and in the second case 0 is reduced to minus 1, that is reduction. where there is a decrease in oxidation number. So these are the different types of redox reactions.